Hello and welcome to Physics Teacher. In this tutorial, I'm going over all the basic information you need to be able to understand organic nomenclature, which is for the grade 12 chemistry class. Throughout the tutorial, as I add more bits of information, we'll have plenty of example questions for us to work through together, and at the end, there's going to be a quiz to see how you've done. Let's get started. First, we're going to start with our 10 alkanes. These are important to remember. So organic chemistry is pretty much carbon chains. So methane is just one carbon with 4 hydrogens attached to it. However, if we were to add a second carbon and continue to attach hydrogens, that would be ethane. If we did another one, that's propane, and then butane, and pentane, and so on. It's good to know the first 10. So the rest are hexane, heptane, octane, nonane, and decane. Now, before we get started, there are different ways to draw all of these compounds. The one I just did was our bond line formula. However, there's a condensed formula, which looks like this. And finally, there's a line drawing. In our line drawing, each vertex is essentially a carbon atom. And if we don't specify otherwise, then those carbon atoms are filled with hydrogen, enough hydrogen at least, to make them happy. All right, next is alkyl groups. So we could have a carbon chain, and then instead of having a straight chain, we can attach groups to that chain. Now, if we simply attach carbon and hydrogen groups, these are alkyl groups. So R represents our parent chain. So for example, we might have, let's have like butane here, or let's do another. Let's have pentane. And then we have all of these hydrogens attached to it. However, what I could do is on that chain somewhere, I could attach another group. That is a 1 carbon group, that's a methyl group. If I attached a 2 carbon group, that's ethyl. 3 carbon would be propyl. 4 carbon is butyl. Now, with propyl and butyl, there are some interesting exceptions which I'm going to mention here for both of them. Now for methyl, you can see I attached to that first carbon. However, if I were to attach an ethyl group, I could write it here, C and C. There's an ethyl group. Doesn't really matter if it's the first one or the second one, you get the same shape. However, if you have a propyl group, I could attach the main parent chain to the middle carbon atom instead of one of the carbon atoms at the ends. In that case, I have to specify it. I will call this propan-2-il, indicating that we are connecting our parent chain to the second carbon in our propyl group. Now there is a more familiar name for this. This can also simply be called isopropyl. Now it's the same thing with butyl. If I take the parent chain and connect it to the second carbon, I have to say butan-2-il. Alright, so let's go over an example of this and put it together. Here we have our parent chain that I've already labeled 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 carbons in our parent chain. That is octane. And then we can see we have a 2 carbon chain or an ethyl group attached to the 4th carbon. So how we're going to say this is we're going to say 4-ethyl octane. Now, whenever we're having a number next to a letter, we always have a dash. So 4-ethyl octane. All right, now it can get a little bit more complicated, so let's go over some rules. The first thing you're going to do is start by finding the longest chain. The longest chain is called the parent chain. So if you were to look at this example here, we could try finding the longest chain. You might go, so this is a carbon atom. So 1, 2, 3, 4, 5, 6, 7. Is that the longest? Well, let's try another one. What if we did 1, 2, 3, 4, 5, 6, 7, 8. That one's definitely longer. So let's use this one as our parent chain. So our parent chain is octane. Now we can see this is a single carbon group. So here we have a methyl group. And over here we have 1, 2, 3. We have a propyl group. So when we're naming this, who's going to get priority? We're going to give a methyl group the priority because it comes first alphabetically. So M comes before P in the alphabet. So when we're numbering our longest chain, we're going to try to give methyl the smallest number it can have. So we can number the chain in two ways. I can number this carbon atom 1, 2, 3, 4, 5, 6, 7, and 8. Or I could start numbering it this way. 1, 2, 3, 4, 5, 6, 7, 8. Now if I do it the first way, methyl is getting the 6th carbon. Where if I do it the second way, it's getting the 3rd carbon. So we're going to prioritize that lower numbering system. So we're going to ignore the blue numbers that I've written here. And so we will say, since our methyl group is attached to the 3rd carbon, we're going to say 3-methyl. And now keeping the same numbering system, we see that our propyl group is attached to the 5th carbon. So again, dash, because we put dashes between letters and numbers. So dash 5 dash propyl octane. So this is called 3-methyl 5-propyl octane. Okay, so well in this case we had a methyl group and a propyl group. But what would we do if we have 2 methyl groups or 3 ethyl groups? In that case we're going to use prefixes di, tri, tetra, if that same group appears more than once. So let's start and find our longest chain. So let's try here. So we go 1, 2, 3, 4, 5, 6. Okay, you can try some other change, but that works. It looks like 6 is going to be our longest, so we have hexane. And which are we going to prioritize? So we have a methyl group. Here we have a propyl group where it's attached to the 2nd carbon. So we'll talk about that in a second, but we did say what that would be called. And then we have another methyl group. So again, methyl comes before propyl in the alphabet, so we're going to start with methyl. So we can start counting 1, 2, 3, 4, 5, 6. Or we can go the other way. Which way would work best? Well, for methyl, it looks like whichever way we get, we're going to be getting 2 and 5. But if we count the other way and go 1, 2, 3, 4, 5, 6, our propyl group is on 3 instead of 4. So let's prioritize our lowest number chain. So that's how we're going to number it. And we've got a methyl group at 2 and at 5. So we're going to do 2, 5. Whenever there's a number separated by another number, use a comma. And then, like I said before, a number separated by a letter, use a dash. Now because we have 2 methyls, we're going to say dimethyl. So we have 2, 5, dimethyl. And then we have a propyl group. Now on the 2nd carbon atom. So we had 2 options. We could say isopropyl, or we can say propan-2-il. So here we have 2,5-dimethyl 3-propan-2-il hexane. Everyone following along? Been through a lot? Let's take a break and have a quiz. These are 2 questions. I want you to try them. If you need time, pause the video right now, give them a quick try, and then continue the video and we'll see what answers we get. All right, so let's go over these ones. We'll start with the first one. This will be our first one. and we want to find the longest chain. So it looks like the longest chain is going to be here. So that's our longest chain. We have 1, 2, 3, 4, 5, 6, 7 carbon in that chain. So that chain, the parent chain, is heptane. And then attached to it, it looks like here we have an ethyl group, and here we have an ethyl group, and then we have a methyl group here. So what comes first, ethyl or methyl? In this case, E comes before M in the alphabet. So let's prioritize those numbering. So where are we going to start numbering the chain? If we start up here with 1, then we have 1, 2, 3, 4, and 5. Or if we start over here with 1, we have 1, 2, 3, and 4. So those are lower numbers. That's how we're going to prioritize them. So there's our parent chain. And so we have 3, 4, and 2 of them, so diethyl. So 3, 4, diethyl. And then we have a methyl attached to 2, so dash 2 methyl heptane. 3, 4 diethyl 2 methyl heptane. Everyone good? Did you get it? Let's try the second example. Alright, so in this example, it looks pretty clear what the longest chain is. So we have 1, 2, 3, 4, 5, 6, 7, and 8 carbon parent chain. So this one is going to be octane. And then we have 1, 2, 3 methyl groups. I'm going to start numbering over here, because that is where we are going to have the smallest numbers. So we have 1, 2, 3, 4, 5. So we have 2 on the 3 carbon and 1 on the 5 carbon. So we're going to label this 3, 3, 5, trimethyl octane. So 3,3,5 trimethyl octane. Everyone good? All right, let's move on to some new stuff. Cyclic alkanes. So cyclic alkanes are when we form a ring with all of those carbon atoms. And when we do that, we give it the prefix cyclo. So this has 1, 2, 3, 4, 5, 6 carbon atoms. So it's a hexane. But since it's in a ring, it is cyclohexane. Now we can attach groups onto our cyclic alkane here. So in this example, here we have a methyl group, and here we have a methyl group. You're going to start counting at one of the methyl groups. So this could be 1, 2, 3, or you can go the other way and start here, 1, 2, 3. Either way, you have a methyl group at carbons 1 and 3. So we're going to label this 1,3 dimethyl cyclohexane. Is that good? Let's try an example on your own. Give this a try. Pause the video if you need to, and then we'll go over it together. All right, let's do this one together. So here we have 1, 2, 3, 4, 5. So this is pentane, and it's in a ring, so we have cyclopentane. And attached to it, we have 1, 2 ethyl groups. And we can label them 1 and 2 or 1 and 2, doesn't matter. So it's going to be 1, 2 diethyl cyclopentane. Everyone get it? Good. Let's move on then. Alkenes. So alkenes with an E now contain at least one double bond between 2 carbon atoms. So for example, this isn't ethane, it's ethene, showing us that we have a double bond here. This one is propene. Now it doesn't really matter where we put the double bond, it's still going to be propene. we don't need to specify where it is, because if you simply rotate it, it's the same thing, right? So if we did 1, 2, 3, and if we attach it at 1, that is the same thing if I were to do this right here. And in this case, I would simply start counting here, 1. Right, so we don't need to specify a number in either of these two cases because it's obvious where that double bond will be. However, if we have more than 3 carbon atoms, we need to say where that double bond is. So this is butene, but we need to specify that that double bond is, or at least starts, on that first carbon atom. So we're going to call it but-1-ene, or but1-ene. Okay, so for example, in this case we have a carbon chain of 1, 2, 3, 4, 5, 6, 7, 8. And we have double bonds in here. So that's octene, but we need to say where those double bonds are. So if we label them, they're at 2, 4, and 6. Again, we have multiple double bonds, so we're going to use our prefixes. So since there's 3 of them, we're going to say tri. So this is called octa 246 triene. All right, what about in this case? So I've got the parent chain number for you, and you can see we have a methyl group and a double bond. So when we're numbering, what do we prioritize? Well, I've already written the numbering for you because we're always going to prioritize that double bond over any group. So we're going to start the numbering closest to the double bond. So this is going to be, we have a methyl group on the 5th carbon atom. So we have 5 methyl, and we have a 7 carbon atom chain, so hept, with the double bond starting at 2, 2-ene, 5 methyl hept 2-ene. We can also put double bonds in our ring structure. And again, we're going to start counting where the double bond is, because that's what we're going to prioritize. So this would be 1, 2, 3, 4. So our methyl group is on the 4 carbon atom. So it would be 4-methyl cyclohexene. Okay, we don't need to say hex 1-ene. That's sort of implied if we don't specify it. Okay, you ready to try some yourself? Let's try these 3. Pause the video here, give them a try, and then we'll go through them together. All right, let's start with this first one here. So here we have 1, 2, 3, 4, 5 carbon chain, and there's some double bonds in there. So this is a pentene, but there's 2 of them. We have to label where they are, and it makes more sense to start counting here so that we have lower numbers. So 1, 2, 3, 4, 5. And the double bonds are located at 1 and 3. So we're going to call this penta 1,3 diene. So penta 1,3 diene. Everyone get that one? Let's try number 2. So in this case, we have 1, 2, 3, 4, 5, 6, 7. So this is a heptene chain, and we are going to start counting from over here, because the double bond appears at 2 here. So 1, 2, 3, 4, 5, 6, and 7. So we have double bonds at 2 and 4. And we also have methyl groups at 2 and 4. So we're going to call this 2,4 dimethyl. And our chain is 7, so hept. And then 2,4 diene. All right, let's look at our last example before moving on. Number 3. So we're going to start numbering our ring where the double bond is. So we got a 1, 2, 3, 4, 5, and 6. So this is a hexene with our double bond at 1 there. And then we have 2 methyl groups at 3 and 4. So this is going to be 3, 4 dimethyl. and cyclohexene. All right. Let's keep going. There's lots to do. Alkynes. So we had alkanes, alkenes, and now we have alkynes. Alkyne is when we have a triple bond. So this, for example, 2-carbon chain with a triple bond is ethyne. Now you're never going to have methine because there's only 1 carbon there. Same with methene. Those won't exist. You can't have a double bond between 2 carbons if you only have 1 carbon. Okay, so there's ethyne. Same rules with our double bonds. So let's go jump into an example here. So here we have a longest chain is 6 carbon atoms with a triple bond right here on the second one. And then we have a methyl group attached to the 4th carbon. So we have 4-methyl, our 6-carbon chain, so hex, where the triple bond is at 2. So 2-ine. 4-methyl hex 2-ine. All right, lots of examples for you in this quiz time. So pause the video here, try each one, and come back when you're ready. All right, starting with our first one, we have a 3-carbon chain. And it looks like it's on the 1st carbon. Even if it was over here, it would still be the 1st carbon because that's where we would count from to have the lowest possible number. So this is simply propyne. All right, what about this one? This one we have 4 carbons. So there's a possibility for different situations here. So we have to say where that triple bond is in this situation. And it looks like the triple bond's going to be on the 2nd carbon. It doesn't matter which direction you start counting from, it's on the 2nd carbon. So this one is going to be called but 2-ine. Okay, what about this 3rd one? We have 1, 2, 3, 4, 5, 6. So that's a hex. And it looks like 1, 2, doesn't matter which direction we count it on. It's the 3rd one. So this is hex 3-ine. Okay. Similar with this one, we have 5 and we're going to count from the right. In this case, it does matter. The lower number is 2 instead of 3, counting from the left. And so this is going to be pent 2-ine. And finally, on this last one, looks like we have 1, 2, 3, 4, 5. So we have a 5-carbon chain with a methyl group attached to that 4th carbon. So this is going to be called 4-methyl. And a 5-carbon chain, so pent, with that triple bond on the 2nd carbon, so 2-ine. 4-methyl pent 2-ine. How did everyone do? Ready to move on? Let's keep going then. Aromatic hydrocarbons. So when we have a ring structure like this, where we have alternating bonds, single and double bonds, which makes it very stable, this is called a benzene ring. Okay, and there are different ways to draw a benzene ring. If you want to draw out every single and double bond, you can do it in this first way. Otherwise, if you just want to show that this is a nice structure where, you can rotate it and you can't really tell where those double bonds are because they can be anywhere if you're rotating it, you can do it nicely like this. Or you can do our last structure like this, which I think is most commonly used. Now, there are 2 ways that we can name a benzene ring. Number 1, we can start with the ring and have groups attached to it. In that case, here we have 2 methyl groups and 1 ethyl group. Ethyl is going to take priority, so we start numbering here. So 1, 2, 3, 4, 5, 6. Okay, so this is our benzene ring with an ethyl group at 1 and a methyl group at 2 and 4. So we're just going to name it 1-ethyl 2,4-dimethyl benzene. So that's when we have groups bonded to the benzene ring. But what would happen if we have a long carbon chain and we attach a benzene ring as a group itself? In that case, the benzene ring is going to be called a phenyl group. So in this case, we have a 1, 2, 3, 4, 5 carbon chain, so that's pent, with a double bond at 2. Again, we're going to prioritize that double bond. Then we have phenyl groups at 2 and 4. So we're going to call it 2,4-diphenyl pent-2-ene. 2,4-diphenyl pent-2-ene. Got that? Why don't you try some? Pause the video here and give these a try. So in our first one, it looks like we've got a nice benzene ring and we've got a methyl group and an ethyl group attached to it. The ethyl group is going to take priority, so let's start counting here. So 1, 2, 3. So this is going to be 1 ethyl, 3 methyl, benzene. All right, let's try the second one. Let's do this one. We'll make that the second one. All right, so we got a benzene ring with 3 methyl groups. So let's count here. So we'll have 1, 2, 3, and 4. So this is going to be 1, 2, 4 trimethyl benzene. Not so bad. All right, number 3. This is our second way of naming because it looks like we've got a nice long carbon chain here. And attached to it, we have a methyl group and a phenyl group. All right, so it's going to make more sense to start counting from over here because it doesn't matter which direction we count from. The methyl group is going to be on the 3rd carbon. But counting from this direction, the phenyl group's on the 2nd instead of the 4th if we counted from the other direction. So we're going to count in this direction. But we're still going to say methyl first because M comes before P alphabetically. So we have 3 methyl, 2 phenyl, and then this is a pentane carbon chain. No double bond, so just pentane. All right, number 4. Similar, we've got a nice long chain. You have to be careful in this one. The chain's going to go down here because they're saying there's 2 carbons. And then we have a methyl group and a phenyl group. All right, we're going to prioritize the methyl group alphabetically. So we're going to start counting from this end. This is where you have to be careful. This has 2, so this is going to be 1, 2, and this is the 3rd carbon in the chain. 4, 5, 6, 7. So that's a 7 carbon chain with a methyl group on 3. So that's going to be 3 methyl, 5 phenyl, heptane. All right, 3 methyl, 5 phenyl heptane. Now this one's interesting because we could simply say this is butane with a phenyl group on the 2nd carbon. So you could say 2-phenyl butane. But we can also use the other naming system and say this is a benzene ring connected to the 2nd carbon in a butyl group. So in that case, it would be, if you remember, but2-ol and then benzene. But in my class, if a student were to write, and if any of my students are listening, don't worry, if you were to write 2-phenyl butane, I would be okay with that. That is correct as well. We're about halfway through, and if you've made it this far, you're doing great. The rest is pretty much adding more groups. So let's start with our organic halides. So these are our halogens on our periodic table. So things like fluorine, chlorine, bromine, and iodine. And we can replace a hydrogen with one of these halogens. And when we do so, we are going to change their names to fluoral, chloral, bromo, and iodo. And then we just have to say where we're putting them. So let's look at this first example. So we have a 4-carbon chain, so that's butane. And then right here, we have a bromine, and right here, a chlorine. Now, bromo is going to come first. Once again, alphabetical order. So we're going to say on our first carbon, so we have 1 bromo, and on our second carbon, 2 chlorobutane. Not so bad. Let's look at this one. So here we have a 2-carbon chain, so that's ethane. And on the first one, we have 2 fluorines and 1 chlorine. So chloro is going to come first. Again, alphabetical order. So you have 1 chloral, 1, 1. And because we have 2 fluorines, we're still going to use those prefixes. So difluoroethane. 1 chloral, 1, 1 difluoroethane. All right, why don't you try some? Try these 4 and see how you do. Pause the video here and come back when you're ready. All right, so for this first one, we have a benzene ring. And it doesn't matter where we start counting, whether it's here or here, but we want the lowest possible numbers. So we're going to have a chlorine on both our first and second carbon atoms. So this one, we are going to have 1, 2, and there's 2 chlorines, so dichloral, and benzene. How'd you do? Did you get it? Let's try the second one. So on this benzene ring, we have a chlorine, a chlorine, and a 1, 2, 3 propyl group. So we're going to prioritize the chlorine, again, alphabetical order. So we're going to have 1, 2, 3, and 4. So on 1 and 2, we have our chloral. So we have 1, 2, dichloral. And then we have a propyl group, so 4 propyl. And benzene. All right, third example. Here we have ethane, and we have a bromine on both 1 and 2. So we're going to name this 1, 2, dibromo, ethane. And over here, be careful, this isn't a benzene ring. We've got a 6-carbon ring, so that is cyclohexane. And we have a bromine on, we're just going to call it 1 and 2. So we have 1, 2, again, like the previous one, dibromo. But in this case, cyclohexane. All right, let's continue. Alcohols. So when we have a hydroxyl group, that's OH, that is an alcohol. And how we're going to name it is we are going to change the ending to -ol. So for example, this one instead of methane is methanol. This one is ethanol. Now we have our primary, secondary, and tertiary alcohol groups. And that just all depends on whether or not we have one chain attached to carbon, or 2 completely different chains attached to carbons, or 3 chains attached to carbon. So let's practice with naming. So for ethanol and methanol, we don't really have to say where the alcohol or the hydroxyl group actually is. But for propanol, we do, because we could put it on the 1 here, or we could put it on the 2 there. So we have to specify. So in this case, we're going to have propan 1-ol, and this one propan 2-ol. If we have more than one hydroxyl group, then we are going to use prefixes again. So we're going to have diol or triol. So for this example, here we have ethane. So we're going to label this ethane 1,2-diol. here we have a hydroxyl group on each carbon in propane. So this is propane 1,2,3 triol. Now these two do have special names. This is ethylene glycol and this is glycerol. But for my students, just stick with the naming. You don't have to memorize those. And finally, if we stick a hydroxyl group onto a benzene ring, instead of being a phenyl group, it is phenol. All right, we ready to try some examples? Pause the video, give these a try, and when you're ready, come on back. Okay, so here we have 1, 2, 3, 4, 5, a 5-carbon chain. So that's pentane, but we have an hydroxyl group on the 3rd carbon. So this is going to be pentan 3-ol. Pentan 3-ol. This one, like I showed you before, this is our phenol. And over here we have 1, 2, 3, 4, 5, 6. So we have hexane, and we have a hydroxyl group on the 2nd carbon. Remember, we still want the lowest number, so we're going to be counting from the right. So this one is going to be hexane 2-ol. Not so bad. All right. Let's look at ketones and aldehydes. Now, ketones and aldehydes look fairly similar because they have a carbon double bonded to an oxygen. So what's the difference? For ketones, in this diagram here, both A and B are alkyl groups. But for aldehydes, one of them must be a hydrogen atom. That would mean that it's on the end of our carbon chain. So let's start with ketones. How are we going to name ketones? Well, it comes right from the name -one. So we're going to place the E ending with -one. For example, here we have propane, but on our middle carbon, we have a double bond to an oxygen. So this is propanone. See how we replace the ending to -one. Now in this case, we don't need to say propan to -one. Why not? Because if we put the oxygen on either the first carbon or the last carbon, it would no longer be a ketone. It would become an aldehyde. Okay, because it would be at the end of our chain. However, if we go into a longer chain, like 4 carbons or longer, we're going to have to specify. So here we have 1, 2, 3, 4, 5, 6, 7. So here we have heptane. And on our 2nd carbon, we have that double bond to the oxygen. So this is going to be heptane 2-one. In this case, we have to specify it. What do you think these are called? Pause the video, give them a try. All right, so let's go over the first one. So we have 1, 2, 3, 4, 5, 6. We have hexane, and we have that double bond to the oxygen, counting for the lowest numbers, on the 3rd carbon. So this is going to be hexane 3-one. How about this one? This one's butane, right? And that butane is right here. And so we're just going to say butanone. Why do I not need to specify it? Well, because it can't be on the first or last carbons, because then it would be an aldehyde. And it doesn't matter whether I place it on this carbon or this carbon, because whichever one it is, we're going to count that as the 2nd carbon in the chain. That would be the lowest number. So if we say butanone, it's obvious that this must be what the chain looks like. All right, so what about aldehydes then? How are we going to name aldehydes? Well, that also comes from the al. So we have that double bonded oxygen right at the end of our chain. So if we have methane with a double bonded oxygen, this is methanol. Ethane becomes ethanol, and propane becomes propanol. In this case, because it's always going to be at the end of the chain, you do not need numbers. All this organic chemistry starts to get hard to pronounce. You don't need numbers. All right, so here's an example. What's this called? This shouldn't take you long. Take a quick guess. You got it? Got 1, 2, 3, 4, 5, a 6 carbon chain with that double bonded oxygen on the end, so that's our aldehyde. This is hexanal. Okay, a few more. Carboxylic acids. All right, so carboxylic acids, on the end of our chain, we have the double bonded oxygen, but instead of a hydrogen, we have a hydroxyl group. So we've got both of them present there. They're typically, when you see them in an equation, have that COOH there. And some common examples, we have citric acid, benzoic acid, and acetylsalicylic acid. This is something my grade 12s will have to make for their final exam at the end of the year. So, how are we going to name them? Now, these more complicated ones, we don't have to. I don't expect my students to have them memorized. But if I give you a simple one where at the end of our chain we have a double bond to an oxygen and a hydroxyl group, then we simply are going to replace the ending of the alkane, get rid of the E, and write oic acid. So methane becomes methanoic acid, ethane becomes ethanoic acid. And what do these two become? Give them a try, pause the video, let me know what you get. All right, so our first one, we have 1, 2, 3, 4, a 5-carbon chain. So that is pentane, but we're going to change it to pentanoic acid. Okay, this one we have 1, 2, 3, a 4-carbon chain, and then our double bond oxygen and our hydroxyl. This one is butane, and so it becomes butanoic acid. All right, next, amines. So amines is when we throw in a nitrogen in there, right? Similar to alcohols, we can have our primary, secondary, and tertiary amines. And we actually have two different ways we can name it in this case. So, for example, take methane. So we have methane with 3 hydrogens, but instead of the 4th one, we have a nitrogen with 2 hydrogens. Okay, so this is going to change methane to methamine. Now the other possible option is to say aminomethane. I prefer the first case, but on my tests, I really don't care which one students use. So now in this case, we have propane. So we have a 3-carbon chain, and we have our NH2 on the 2nd carbon. So we're going to have to specify that now. So it becomes propan-2-amine. Again, you could also say 2-aminopropane. Give these a try. So for our first one, we have a propane chain with nitrogen on the last or the first. We're going to say it's the first, right? We want the smallest number. We don't want to say 3, but we are going to have to specify it because we could put it on the 2. Can't put it on the 3 because then that would just become 1. So we're going to have to say propan 1-amine. And for this one, we have butane, and it's on the 1st carbon. So similarly, butan 1-amine. All right, let's look at some more groups. So these are ethers. So with ethers, we're going to have an alcohol react with another alcohol. So the OH of one alcohol will react with H from the other alcohol, and that just gives us our water. And then we're left with this oxygen that helps to link the chain of our 2 alcohols. So how are we going to name this? Well, we've got 2 chains here. We are going to start with the shorter chain, and then we're going to replace the ending with oxy. So in this case, we have methane and ethane. So methane is our shorter chain, but we're going to replace methane with methoxy. And then we're going to name the longer chain, which is ethane. So this is methoxyethane. If we take a look at this example, so we've got 1, 2, 3. That's clearly our longest chain. So that is propane. Now we have 2 of these connections. Okay, so in this case, we have ethane and methane. Now again, we're going to prefer the ethane because it comes first alphabetically. So this is where we're going to number it 1, 2, 3 instead of the other way around because we're preferencing ethane. So ethane is attached to the 1, so we're going to have it 1-ethoxy. And then we have methane on the 3, so 3, forgot the dash there, 3-methoxy. And then the longest chain, propane. So 1-ethoxy, 3-methoxy propane. Try these two. Pause the video and then come back when you're ready. All right, so there's that oxygen there. And then here we have a methane chain, and here we have a propane chain. So propane is clearly the longer chain. And so if we count starting 1 here, 1, 2, 3, again, we want the lowest possible number. We're going to have 1-methoxy and then propane. 1-methoxypropane. Well, how about here? There's our oxygen. So this chain, we have 1, 2, 3. So we have a propane. And over here, 1, 2, 3, 4. So we have a butane. So butane is longer. So attached to the first one, we have 1 propoxy butane. Not so bad. Let's keep going then. We're almost there. Esters. So when we have an organic acid, okay, so there's our organic acid. In this case, we have ethanoic acid and an alcohol. So here's our hydroxyl group. Okay, we have the hydrogen from the alcohol combining with the hydroxide from the acid. That's going to make our water molecule. And then we have this oxygen right there combining the two together. So this is an ester. How are we going to name the esters? Well, we're going to start with the alkyl group from the alcohol. So our alcohol in this case is methanol. So we're just going to name that methyl. We're just using the alkyl group. Then we're going to take our acid, which is ethanoic acid, and we're going to replace that with OH. So it becomes methyl ethanoate. So if we look at this one, okay, so here is our acid. We can tell that because it's got the double bonded oxygen. Here's where the connection was made. So this was our alcohol. So the alcohol was propanol. So we're just going to take that alkyl group, propyl, and change ethanoic acid to ethanoate. So this is propyl ethanoate. Let's try some examples. Pause the video here and then come back when you're ready. Okay, so let's look at this one. So here we clearly had the acid, okay, and that was a 4-carbon chain. So that was butanoic acid, and it combined with, here was our alcohol, which would have been just methanol. So we're going to take the alkyl group from our alcohol, which is methyl, and we're going to change butanoic acid to butanoate. Okay, if we look over here, again, there's our connecting oxygen with our acid, or what was once an acid, and our alcohol. So our alcohol is again methanol, so we're going to have methyl. Okay. But our acid was a 3-carbon chain, so it was propanoic acid, which is now going to be propanoate. All right, let's keep going. All right, amides. So if we have an organic acid, so here's our acid, and we combine it with ammonia, what's going to happen is one of those hydrogens mixed with the hydroxyl group on our acid is going to make our water. And then we are left with this here linking the chains. That's what you want to look out for. So how are we going to name this? Well, we're going to take our acid and we are going to replace it with amide. So ethanoic acid, so get rid of this, and we have ethanamide. Here we have a 3-carbon chain, right, with our NH2 stuck to the end, with our double bonded oxygen. So this is how you can sort of see it's different from an amine. And so we're going to change propane, or changing propanoic acid, to propanamide. We got that? All right. Try these two. So we don't need numbers because they're at the end of the chain. So this is going to be butane, or butanoic acid, changes to butanamide. And ethanoic acid changes to ethanamide. All right, we have reached the end. So now I'm giving you an 8-question quiz. Pause the video here. I want to see how you do. Try these 8 questions. They are a little bit challenging, but if you use everything we have learned, you should be able to do them. When you're ready to see the answers, come back in 3, 2, 1. Here are our answers. Check them and tell me what score you got in the comments. Thanks for watching that extra long tutorial on organic nomenclature. I hope it helped.